So in these examples, we're going to take a look at what happens when we do operations of adding, subtracting, and multiplying with complex numbers. And you'll see that when we do this, that I is just treated like a variable unless we get one of those special i's that has an exponent on it other than 1, because they need to be substituted with their value. So if I have a subtraction problem, this would just be like exactly the same if these were x's. You know, if this was an x and this was an x, you would simply distribute and combine like terms. That is exactly what we're going to do. So following PEMDAS, we're going to distribute this into here. Okay, and that will give us negative 8 minus 5i. And then the other part of the problem is just going to drop down. And then we are going to combine our like terms. So remember that when you have a complex number, that it's going to be written, it's really important to remember that complex numbers are written as a plus bi, which is kind of a hard habit to break from regular algebra because you want to put the variable first, but we want to put the real part first. So 2 in negative 8 is negative 6. And then 3i minus 5i is negative 2i. 6 being the real part and 2i being the imaginary part. So over here we have a little bit more distributing to do. So let's see what happens if we distribute this I here. We will get 2i plus 3i squared. And then here, if we distribute this 5, we'll get 40 plus 25i. And so I wanted to show you this because what ends up happening is we end up getting something that looks like a quadratic. But please keep in mind that imaginary numbers or complex numbers are actually kind of, I forgot to put my square here. I times I is I squared. That's what I meant by it looks quadratic. So when you write this out, you know, some students will say, okay, we have a 40. It has no like term. We have a 2i and a 25i. So that would be 27i. And then we have our last part here, the 3i squared has no like term. And you'll realize later, like if you go back and watch that video, that should actually bother you that I didn't change this. Because this right here, it has to be changed to negative 1. So this is really 3 times negative 1 or negative 3. A complex number is never going to have 3 or 4 parts. It can only have 2. So I'm now going to put the 40 with the 3, and the actual answer is 37 plus 27i. And you'll see me do that from now on. If I ever see a variable with an I, that's an I that has any power, I'm immediately going to change it. All right, let's take a look at 3. So again, you could FOIL this if you want. If you want to FOIL that out, you can. You've probably learned by now that I don't really like FOILing because this visual boxing method is just so much better in terms of checking your work and seeing like terms. So this goes in the column. And this goes in the row. And so 3 times 2 is 6. 3 times negative 5 is negative 15i. 2 times 2i is 4i. And negative 5 times 2 is negative 10, and then I times I is I squared. And again, the box method is great because now you can clean up these extra I squareds. That's really a negative 1. So this box's value is overall, it's positive 10 because of negative 10 and then negative 1. So when I combine my like terms, I'll have 6 and 10, which will make 16. And then like terms always appear here with the variable, so negative 11i. Just like you normally would FOIL, but instead of having, you know, you get a square normally with X, you have to write that down in order. In this case, you have to change it. And please don't forget that when you have squares on the outside of parentheses, it actually means to do this. One consistent mistake that I see students make over and over again, and it's hard because I don't want students to make these little mistakes, but they keep doing it, is instead of writing it down twice like this, what they do is they try to distribute this, which is a bit of a, it's just always going to give you the wrong answer to distribute a square over addition or subtraction. So actually, I think I want to modify this. You might remember from the previous slide that I to the third power is actually equal to negative I. So let's just go ahead and see what happens if this is negative I. then the expression that we should have tried to multiply together should have been 3 plus 7i. And that's going to save us a lot of extra work. And if you didn't catch that, it's still going to, the problem will still work out. You'll just have more simplifying at the end. So you're going to want to, anytime you see an I that is not a power, that you, anytime you see an I that's greater than 1, you want to change it. All right, so now that I have that, again, I'm going to box that up. And again, if you're wondering, like, what did he do there, you can just refer back to this. I to the third power is negative I right there. You could also see it in the little table we talked about just a couple moments ago. All right, so here we go. Going back to boxing this up. Okay, 3 times 3 is 9. 3 times 7 is 21i. And then same thing here. Then here we get 49i squared, but of course the square is really -1. So this box is actually -49. That's why I love the box method. It just gives you room to work. 9 minus 49 is -40. And then plus 42i. Okay, so we're going to take a look at division in just a minute. Division is a little bit different. It follows the same rules as radicals. And here you see that subtraction, addition, and multiplication is just like any other variable.